Welcome to my vlog on big data and cybersecurity. My name is Lipyeow-Lim. I'm a computer scientist, an educator, and a software engineer. And today I'm going to be talking about multi-cloud, multi-region federated queries for cybersecurity. This is a fascinating topic because we are encountering more and more organizations, customers who have footprints in multiple clouds, right? Some have infrastructure in Azure and AWS. Some even have infrastructure in all three: AWS, Azure, and GCP. And so what that means for cyber is that, hey, you now need to monitor logs in all three clouds. And again, one naive way of doing this is I would move all the logs to one place, one location. Maybe I like AWS, so I move all the logs to AWS. And then I do all my cyber, log processing and all my detections and hunting on that consolidated pool of data. Now, there are actually problems with that approach. It's very nice and simple, but on the other hand, you're going to be hit with two things. One is egress cost. These cloud providers, they like you to bring data in, so there's no ingress cost, but when you try to take data out of the cloud provider's infrastructure, there's egress cost. And for cyber, when data runs in petabytes and multiple petabytes, this actually adds up. This actually becomes very significant. And second is data sovereignty regulations. There are many cases when you may not be allowed to, may not be legal to actually move data out of one region to another. Again, it depends on the data sovereignty regulations of different countries. If you have data that's residing in a cloud provider region that's in that country, you may not be able to move some of the data out. So these are the two big reasons why you may not want to consolidate all your log data to one place. What do you do then? Well, it turns out that for Databricks, you can actually federate your queries and actually query those data in place at those local workspaces. This is what I'm going to show you today in this notebook. So this is the scenario that I've set up for this notebook. I have two workspaces, two Databricks workspaces in AWS, and I have one Databricks workspace in Azure. And I'm going to assume that these are all cybersecurity lakehouses. These Databricks workspaces are exclusively used to process cybersecurity logs. It's going to be doing detections there, doing hunting queries there. And if you remember my earlier episodes on IoC matching, I'm going to assume that each of this workspace is going to be ingesting the log data from that region, and it's going to be then ingesting into the Delta tables. It's going to be using Delta Live tables to do IoC matching. And for any matches, it will be stored in an IoC hits table in each of this workspace. So you're doing local processing. There's no data egress. So it's very convenient. And I'm going to show you then that, hey, what do you do then? Say, do I have to go to each of this workspace and actually query the data? Well, you don't have to. And that's what I'm going to show you right now. So let's jump right in. There are some prerequisites. I'll leave you to read that on your own because this notebook is available on GitHub. There's additional access controls and permissions you can configure. We do support very fine-grained access controls at multiple levels, at source tables, at external tables, at the union or view. So lots of knobs where you can configure access control. This command just initializes certain common parameters. And this is the one that I want to focus on. So this is the multi-cloud config JSON, and what it specifies the table that we're going to federate, the federated view that we're going to create, and these are the workspaces. The first one is local. The second one is E2Demo West. It's in second AWS workspace. The first one is in AWS as well. And the third one is in Azure. It's an Azure workspace. And you do have to provide a personal access token that's stored in the Databricks secrets. That's what I'm using to store the path. That's why I don't have the secrets exposed here. That's also one reason why I'm using Python code gen to do a lot of this as well. So let's jump ahead. This is code that will actually generate the create table statements. So let's actually go and look at the create table statements, because those will make more sense. And this is pretty much it. The code above will generate a drop table statement for E2 demo OS, IOC E2 demo OS, then a create table statement. And so it's going to create a IOC hits E2 demo OS table that is actually not a local table. It's pointing to a remote Databricks workspace at E2 demo OS in this URL. And it's going to be pointing at this particular table here. Called IoC Matching lipyeow-lim.IoC hits. It's going to do the same for the Azure workspace. It's going to create a IoC hits underscore Azure table that's going to point to the Azure workspace and the IoC hits table there. Now we're actually ready to create the union or view. And let's again look at the actual statement. We're actually creating a view that's called IOC hits federated. And this is created as a union all of, this is the IOC hits from the local workspace. This is the IOC hits from E2 demo West. And this is the IOC hits from the Azure workspace. And now we can actually start testing things, right? So this command, I'm just going to, well, this is really a sanity check for debugging and testing. I'm going to query each of the tables sequentially in a for loop just to make sure that they work. And this is what I get. This is the local table. This is the table from E2 demo West. And you see that all of them have like 73 rows. And this is the table in Azure, right? And so the queries get sent to the remote and the results are brought back. So that's just checks that it works, but this is not really how we will be using it. What we'll be doing is actually query the federated view. And so with the federated view, this will be the query that you will be writing, right? You'll be providing a predicate on the IP address, and that will get pushed down, right? And so with this one query, it is going to actually generate those three queries you see on top behind the scenes and actually fire them off in parallel and actually bring the results back. And this is exactly what's happening here. You see that it brings back 219 rows, which is 3 times the summation of all the results from the above, all right? So this is pretty cool. Let's check the query plan to see if the filters were pushed down. If you don't believe what you're seeing, you do an explain on that federated query, on the view, the query on the federated view, and you get back a query plan. And with the query plan, you have to scroll through a little bit, and you will look for this scan JDBC relation. And so this is scanning a remote relation via JDBC. And if you scroll, you will see, so this is on the IOC hits Azure table, and you would see that there is a push filters section, and it says that, hey, the matched IOC 192.168.202.75, that IP address filter has been pushed to the remote workspace. So the filter will get executed on the remote workspace. Only the results of that filter will get egress and brought back to this workspace. So this is pretty cool, and this essentially enables you to do cybersecurity across multiple clouds and multiple regions without actually consolidating the data and egressing the data to a single spot. And again, when I first tried this, I was ecstatic. I thought this was the coolest thing in a while. But hope you enjoy this, and I'll see you next time.